Today, we're going to talk about Qlik performance. But before we start, let's first look at several common questions that we have received at Qlik support. Here they are. So the first type of question is related to hardware resource. I call it slow machine type of question. The second and third questions are related to the speed. I call them slow action type of questions. So maybe you have also been asked by someone else with these kind of questions before. So hopefully in the end of my presentation, you will have more insight to answer them. Here is today's agenda. First, we will generally talk about the factors that impact performance. I will introduce you a term called Qlik performance triangle. Then we will take a deeper look of the impact from environment, from the application design, from the usage pattern, and those factors. I will also show you examples. Later, if we have time, we will go through some tips for performance troubleshooting. In the end, we will summarize the session with some key takeaways. All right, let's begin. So for different people, they might care about different aspects of performance. For the end user, most likely they cares about the response time. For the system administrators, they cares about something like resource utilizations and number of users, etc. But no matter what performance aspect you are focusing on, you need to understand what are the other factors that actually impact the performance you are working with and how they are working together to impact your performance. To make it easier to remember, we use a term called performance triangle here to help us manage those key impacting factors of performance and also to show how they are connected to each other and how they are also interact with each other. In this diagram, you can see there are three groups to categorize those factors. We have environmental factors, we have application design factors, we have usage pattern factors. As you can see, there are many factors in each of those categories. In the environment, we have number of CPU cores, CPU speed, RAM speed, etc. In the application design categories, we have data model, data size, the complexity of the expressions, and so on. From the usage pattern, we have the number of users, selection per user per minute, and ramp-up time, and etc., etc. So there can be even more factors in all of those groups than those are just listed here. All those factors are linked, and they will impact to each other. Before your performance investigation, you need to identify and list those key impacting factors in your system and try and test them in your system. And hopefully using the triangle will help you to evaluate those impacts. Okay, so next, let's first look at how the environment factor will impact performance. We will use QIX Engine service as an example. As you know, engine service, which also known as a QIX Engine, is a core service in QlikSense. So it is an in-memory program. It utilizes RAM memory to store all the data for analysis. In Engine, there are three types of data that Engine store in the memory. The first type is the original data set from the app data model. That happens when you open up the app, and that will be loaded into the memory. The second type is the session state of all the users in the system. It keeps all the users' session. The third type is the calculated result for all the user activities. And this part is also well known as the cache memory. So the result in the cache memory can be reused by the engine very quickly. So that is one key feature for a performing engine of QlikSense. However, if engine needs to release some memory dynamically for some reason, the cache memory will be purged based on some criteria. The next slide will show you the place to configure this cache memory. In QMC, you will have these settings. It allows you to configure the criteria to manage the cache memory. So you can put numbers here in the settings. Where you can find the settings, yeah. You can find the settings from QMC Engine and select the node name, engine node name, and in the advanced tab, you will find this kind of configurations. So you put numbers in the minimum memory usage, maximum memory usage there, and also you choose the usage mode. The QIX engine, what are those numbers mean? The QIX engine will not purge any cache value before the memory usage reaches the minimum memory usage. But if the memory keeps growing above the memory limit, QIX Engine will start to swap the old cache value with the new cache value, just in order to keep the total usage value under the limit. If the memory keeps growing even further, going above the maximum limit, Engine will start to release all the possible memories just to try to keep the memory usage under the limit. So you will have, you can also set different mode, like I said, for these two settings. Let's look at some examples to show you how QIX Engine actually utilize and release the memory in different situations. So in this example, this is a picture showing at this point a user is opening up an app. Start from this point. This is a timeline. Start from this point, we can see more users coming into this picture. By the way, for the legend, the black color is the memory taken by the app data model, and the dark green color is the memory allocated for the session state, and the light green color is the cache memory. So here, the app is loaded in the memory. At the same time, the number of users keep increasing. And we can see the users doing some activities. Therefore, they start to build up the cache memory. And the cache memory is still to grow as well. Now, a second app has been opened by the user. We can see a significant memory increase for allocating for the second app data model. At the same time, we have seen more users coming in, and they are doing selections activities, and we can see also the cache memory keep accumulating up to this point. So at this point, this is the minimum memory usage limit reached. From now on, the engine will start to swap the old cache memory with the new ones. Now we can see a third app is opened by the user, and this is a heavy app. At this point, it forces engine to purge a big chunk of cache memory. You can see the difference to feed in the third app's data model. And after this point, we can see, and you will be seeing the fluctuations of the memory usage because engine will have to all the time struggling to build up new cache memory and swap with an old one. Apparently, the space for engine to do so is not very good, so it will spend more resource to do so. This will impact your performance. And after a while, the user session starts to time out, engine start to release the memories. Also, when the app memory has been released also from the memory, we can see in the end, the cache memory is actually kept in the RAM. And this one will be cached until the next time engine service will get started. After we have a look at the memory usage, let's have a look on how engine will utilize the CPU and how the CPU will also impact the engine performance. So QIX Engine is a multi-threaded program. Therefore, it is very scalable. It's highly scalable in multi-CPU cores. Most of the time, you will see the high spikes like this throughout all the cores. It means that QIX Engine is trying to utilize as much available CPU power as possible for the calculation. This one means it's good. However, if you see a pattern like this, which is the average CPU utilization is more than 60 or even more than 70%, this means the CPU is saturated now. The saturation means there is no processing capacity for immediately available anymore. For the new incoming selections, they have to be queued and waiting for the calculation. So this will impact your performance. Another situation is you have a pretty idle CPU usage, but yet your performance is very bad. You can see there's activities traveling from one core to another core, like is shown in the picture, and that's it. So this is a sign for the single-threaded operation in your system, which becomes a bottleneck for your performance. So we will look at this issue again in later example. There are many other factors from the environment which may impact your performance. I will just list them here, not going through details of them. Oh, sorry. What? I'm sorry. So the next, let's continue with the application design factors. First, I would like to use this example to show you what actually happened behind the scenes when you have made a selection in your app. Imagine now you have one object, and it has this aggregation in its expression. Sum, number of unit, times unit price. So something now is selected in your app, and QIX Engine will calculate the result for the aggregation with the data set. QIX Engine will do this in steps. First, the engine will walk through the whole data model of your app, table by table, evaluate all the values of each single field to determine which values are possible, which are excluded based on your selection. So basically, that is the thing behind the colors like green, white, and gray you see in your app. And this, by the way, the first step is multi-threaded step. And the second step, engine will calculate for all the objects. It will do the calculation also in two steps. So the step 2 is to create all the possible combination of the values of all the fields that are involved in this aggregation. So in this case, you have two fields, number of units and unit price. If those fields are in the same data table, the aggregation or the combination will be created in the same table. But if those fields are coming from different tables, as we show in our example, these two fields are located in two different tables. Engine will create a temporary table for those fields. That is what you see here in the bottom, together with the keys to connect them. So this step you need to pay attention is this is a single-threaded operation per each object. And the next step is to do actual aggregation, in this case, a sum. So this step is multi-threaded operation again. And then after that, you will have your object calculated and visualized. So now you have seen what happened in QIX Engine for calculation in this very simple expression, and where might become a performance bottleneck since you see there are single-threaded operations in the middle, and also will have a data model traverse to find all the combinations. Now imagine instead of having only two fields in your app, in your aggregation, what if you have 3 or 4 or even more fields involved in your aggregation? What if your fields are far away from each other in your data model? What if you have set analysis, you have if conditions, you have distinct clause which will make any aggregation to be single-threaded in your expression. So in this case, you need to understand a lot of your expressions to understand the performance of QIX Engine. So also imagine if the chart holding this object is your enterprise dashboard, and this table in this object has been used by multiple users on the Monday morning. So how slow performance that could be if you don't pay attention to the aggregations here. All right, so I think we have got enough from this example. In the next two slides, I will show you some live examples of how the application design will impact the CPU performance in a multi-CPU core system. Let's have a look. In the first example, user just opened up the app, which contains several sheets. And you can see the app data model is pretty heavy because it takes some time and and the CPU utilization is actually well spread throughout the course. Now the app is loaded. There is a sheet among those sheets that contains many objects. Now you can see all of a sudden all the CPU cores are utilized and the total CPU is up to 100%. What does it mean? So it means the CPU is saturated for a short while, but it also means all the CPU was utilized by the calculation for all the objects. The reason for this one is mostly because there are more objects in the sheet than the CPU cores available in this system. And the calculation of those objects are actually utilizing as much CPU power as possible. So at this example, we see how the number of objects in the sheet will impact the server performance. Let's see the next example. In the next example, we see the user opens up another sheet. It contains with only one object. You may see it actually takes a really long time to calculate this object. At the same time, if you look at the CPU power, it's actually quite idle, and the RAM as well. Why? If you pay very close attention, you see there and there's always at a time a single CPU core having some activities up to 100%, which is a sign for the single-threaded operations. So the root cause for this behavior is there's a distinct clause in the aggregation function. So this example shows actually if you have a really poor design aggregation in your object, to having a 40 CPU core machine doesn't make this type of calculation any faster. Okay. So here I list other factors from the application design that will affect the performance, and we're going to move forward from it. Next, let's focus on the usage pattern factors. I would like to show you an example in a case study. And here you can see how the usage pattern will affect the performance. In the first picture, we have two curves corresponding to each other. The top curve is a number of user sessions in the system, and the bottom curve is the CPU usage. We can see that along the time when the user session increase, the CPU usage also increase. And when the user session drop down, the CPU usage drop down as well. So it shows the activities from the user session is actually the root impact for the CPU usage. It makes sense, right? Now, in the second picture, we see that when the user session is growing, the CPU usage is growing, it's the same. But when the number of sessions is dropping, we see the CPU usage is growing even more. So the CPU usage somehow is not corresponding to the session of user session, the number of user session anymore. Why? So in order to answer that, we need to have more information. The third picture shows that the number of user session per app in the same system. Here you can see like different color stripes indicating number of users per app. We see here that when the number of user session dropping, the number of user session for the other apps are dropping in this time, the number of user session of this app is increasing. And that is corresponding to the increasing of the CPU power. So the answer is, So answer is, this one is a heavy app, and that requires our special attention to take care of it. So here I list several other factors from the usage pattern, and you can ask those questions when you investigate your performance issue.
Yang, just let you know we're running a little short on time, so I don't know if we'll have time for the performance troubleshooting. Maybe you can just breeze through it.
Right, okay. So let's just go through the performance troubleshooting. I have put it here. First, we want to make sure that we have a well-performing hardware by utilizing a server whitelisted server. You can find documentation from our community. Make sure you have enough hardware resource for your app and calculation. When you have a slow calculation, you can check with a task manager on your server. You can utilize Qlik sense logs, check for the entries, like if the memory is really struggling. And also you will review the app design to find out the slow object and check the expression of it. If you have a slow reload, you can check if you reload sharing resource with something else, and check your script log and find out the slow part of the reload, and use Task Manager to monitor the resource on your server. Also, you can monitor the bandwidth and connector driver stuff. So let's summarize today's presentation. First, I want to say performance is actually a man side. It's not something like a feature you can add on top of your implementation after you have done it. You must understand and be careful with those impact factors before and during your implementation. And you should test the performance with changing one factor in your system at a time and find out which factor impacted your performance the most. You can always go back to performance triangle to remember those factors. And you can utilize the resources like our Qlik community, Qlik support, and consulting service for your help. Here I just list the useful tools I've mentioned in my presentation today. You can use them to understand and test and troubleshoot Qlik Sense performance. And there is a list of links with useful resources. This list will be shipped together with the recording of today's presentation on the Text Expert Thursday page. In the end, just as a reflect, here is the Qlik performance triangle. Hope it will help you to reflect what we talk about today. So that's all from me today. Thanks for listening.